Hi guys, I thought I would do some videos on microcontrollers, so some little projects, and then I thought myself I might make a playlist on my YouTube channel for microcontroller based videos, and then I thought myself I might do a little overview and getting started sort of video here to discuss what kind of microcontrollers I use and the devices and things that I plug into them, what have you, just for a reference and why. So when I got started, the first thing when I got interested in microcontrollers, I got one of these Arduino Unos. This is not actually the really old original one. There was actually one with a serial port on it, I believe, and it had a big chip on there, like 28 pins or something. This is probably Chinese clone. This is actually the chip over here. So it was kind of clever who thought up that Arduino system, because they've got a development environment and they put a USB port on there, voltage regulator, so you can just run it off 9 volt battery or something like that. And interface brought out the GPIO sort of interface pins. As you can see, it's got analog and power and digital. It has pulse width modulation, so all that sort of stuff. It was good, but this thing is kind of showing its age a bit. The actual interface on it too, like the cable, that socket over here and the cable comes with it, is one of those old-fashioned big plugs you would see on early USB printers and stuff. You don't see those much anymore at all, and of course with USB-C nowadays that's all gone. So Arduino people themselves, they make various other devices. This happens to be an Arduino Nano. I got that also quite a while ago, and this was one of the first ones, if I remember correctly. It could actually through the USB port emulate a keyboard on a PC, and as a project that I did, I put this inside of a keyboard, and it was an old PS2 keyboard, so the input went onto one of the digital input pins, and then I was outputting USB output on the keyboard, and could give the keyboard some features that it normally didn't have. So this is an Arduino Nano. I think it's actually probably a little bit faster than the old Arduino there, but obviously it's smaller and it doesn't have some of the I/O on it. In fact, you can get things like this. This is a shield for the old Arduino there that you can plug in. It's got a little breadboard on the top, so you can put components in there. Makes it convenient. Because the Arduino itself, the Uno, you can't plug into a breadboard, so this is the way to go. And if you need a bit more power, the ones that I use then are these kind of STM32s. These guys over here, they've also been around for quite a while. They're well known. People refer to this thing as a black pill, and this one is a blue pill, and they do a good job. They are much faster than the Arduinos. The original Arduino, they're 16 megahertz. This one is like 72 megahertz, and there are versions of these, like that board I just showed you with the F4. I think they run at 160 megahertz. That particular chip's a bit more powerful than the ones on here, but nevertheless they do a good job. This one has USB-C. This one has a micro USB connector. However, you can use those to power it, but you can't use those in order to program them like you can with the Arduinos over there and the ESP32s. So you need some sort of device, a USB to serial device, in order to program these. And you can use an FTDI board, which is what most people have been doing. There's one over here, and these little wires over here, they would just plug into some of the pins on the microcontroller, but I prefer to use it has an interface here, and I prefer to use the official ST-Link device that is made for that sort of job, and it has a USB plug on it, type A, and it plugs into those 4 pins, you know, on the top of these boards. There's this one as well, and so that is a useful device. I've used these. They are, you know, a little faster and a little better than those Arduino ones. Now for really low power and simple projects, I also use these ATtinies. Like here, these are 8-pin Atmel Tiny 85 devices, and they can actually do I2C, so you can actually, just with a couple of those pins, you can address a bunch of sensors and components. And but in order to program these, most people, if you look at YouTube, they use the old original Arduino Uno and plug them, make up a little socket for it and plug it into some of those pins here, and there is some software that you can download in order to program them. What I do though is I use one of these DigiSpark things this way so you can read it. Its little circuit board actually plugs into the USB, and there is some firmware on this is a Tiny 85 on there. There's a bit of firmware in there that allows it to communicate through this rudimentary way through this USB interface. It has a little voltage controller on there, so it can run off 5 volts, and that's basically all it has. So after you program it and everything works, you can then actually, because you know it has the pins over here, it can plug into a breadboard, and once it is working, then you can actually program the code into one of these guys, and on your own circuit board put a little 8-pin socket on there, and off you go. But for many projects, I need something that has Bluetooth and Wi-Fi and so on, and that's where these kind of things come in. There's a whole variety of these. This is a TT Go with an OLED display on it, and has a socket where you can plug a battery into it. It has a battery charging circuit, and this is the actual ESP32 device chip, and there's some flash memory on there and all that kind of stuff. This one will plug into a breadboard, so that there is no problem with that. Also, there is this thing here, which is a I don't know if I can get better to see or not. It's a WROOM version, and I don't know if I can hold it up. It's the light comes and you can't read it too good. In any case, this one here has a socket on there for an antenna, and if you want to make these units and hook them up to maybe outside or something like that, and you want to communicate with them via Wi-Fi or something like that, then you can actually get an antenna. And I have, for instance, I made up for experimentation, I made up a little stand here, and the antenna just screws in there, and there's different antennas you can get. This one is 2.4 and 5 gigahertz, which I actually stole from an old D-Link router, which failed. I've got 2 of those, obviously. These are bought. These are higher performance ones. It's bigger, and it has it is for 2.4 gigahertz, which is what the ESP32 does. And this thing then has a it's on a socket there, and has a little lead coming out of it, and that little lead has one of these plugs on there, and it plugs into that little socket over here. And so you can make like a mesh network. These things can communicate over longer distances because they have an external antenna. Most of the ESP32 devices like this one here, the antenna is actually under the little logo here. You can see it there. It's like some little traces on the PCB. So these can't go, very far, obviously. And the next thing that the ones that I showed you I kind of bought on AliExpress, and it can be difficult for some of those to get schematics and documentation, but there are some companies like M5. This is an M5 stamped C3. This is a ESP device as well, and this, you can plug this into the breadboard. Obviously there's actually a button hidden under there somewhere. Where is it? Yeah, over here. If you press over here you can feel clicking. Yeah, it's actually just G3 button. Now this is an interesting company. We'll look at the website in a minute. They make apart from these things, they make these modules that all stack together, and you can make up, if you're not into doing the electronic side of things, you can buy little modules and sensors and stuff. Seeed Studio, Chow. This is an ESP32S3, and this is a C3. And there is also a version over here that has the Raspberry Pi RP2040 on there. So these guys here got different microcontrollers, actually the core controllers in them. One is an Xtensa X7 or something like that, and I think it's the S3. And the C3, I think it has a... Yeah, so the C3 has a RISC-V controller in it. And these guys also have antennas sockets, and they came with these little stick-on antennas. They have sort of sticky tape on the one side, so if you put this in a little enclosure, you can actually stick that to the side of the enclosure and the antenna is done. So these guys here, they don't actually, if you buy them from Seeed Studio, they don't actually come with little pins, and in fact I don't like soldering pins on those. I have made up a little adapter for them, and because once I've got these things programmed and ready to go, I want to solder them on my own PCBs, and the pins would just get into the way in the way. But during development I might want to have them connected to a little breadboard. So in order to do that, you can get these pogo pins, and one side, this side here, solders into the PCB or a perf board, and that pin over here is spring loaded. So when you look at it from the side over here, put these aside, you'll see that the little pins, they can be pushed in. So what I do is I made up this specifically for these Chow boards. The little pins make a good contact there. Then all I need is a little rubber band which to put around it to keep them on there, like so. and it's got USB-C port to plug into, and as you can see from the side here, you see they're spring-loaded. Whatever, they make a good contact because they're gold-plated, and so are the little ports. And then on the bottom here is the pins that will plug into the breadboard. So that's how I do that. But if you buy, you can obviously, if you're experimenting and you're not planning to use them for anything else, you can actually solder the pins on, obviously. So another thing that I have is this Expressive. You can buy these specialized devices. This is an S32 S3 USB OTG, and rather than take it out of its box, let's go to the website. ESP, Expressive, they have lots of documentation. This is that device I just showed you. This is ESP S3 USB OTG. Now the idea is that one side, did I have a better picture of it? Yeah, one side is a USB host interface. It's a female type A USB socket. Then there's a device interface, which is the type A male socket. And I had this idea of doing a little project. If it comes to fruition, you'll know about it. To plug a keyboard into the host interface, because that's what you need. USB comes in different flavors. There is a device or a host mode that these things run in, and this one has both. So plug a keyboard into there, then I can write some code in order to pick up the keystrokes. Then I can process them and do some work on them and stuff, and encrypt them or whatever. This is where I have an idea, and then output them on this interface here. So it goes between, like a dongle between the keyboard, and this one has a third USB interface here, a micro USB, which is the actual thing that powers the board and how you program it through. And this is the ESP Mini 1 module, which is actually this little board that's actually soldered onto this board as well. Has some buttons. It actually has a micro SD card slot as well, so you can put some data on there, which is what I was planning to use as well. You can put lookup tables in there for decoding and stuff. And so that's why I bought this thing. And as I said, when these kind of things, if you're trying to do some tricky projects, you really want to make sure that you got information available, so you're not pecking and hunting trying to find out the information. It even has battery solder joints there and some pads for some extra pins to come out and so on and what have you, and it has a little display on it as well. And this is a functional diagram, and this shows you how you can take one of these little lithium battery packs there, soldered onto there, and it's got the circuitry inside to charge them already, and of course it's got the schematics or circuit diagrams, whatever you call those. So I'll be all set. I've got to study up on this stuff and get that going. If that project works, as I said, I'll make a video on it and you'll find out about it. If it doesn't work, I'm not going to say nothing. Anyway, yeah, so as I said, when it comes to these microcontrollers, you have to make sure you've got good information on them. Now when it comes to the ESP, they support Arduino. They also have their own Expressive has their own development system, but I tried it out. It's called IDF. It's got a bunch of tools and everything. It's just not as easy to use as like Arduino or Platform IO, which is the two systems, the development environments that I use. So they have some information here about, you know, how the ESP32 works with Arduino and the different types. There's a standard ESP32, the S2, which has really been superseded by the S3 and the C3. Works on Arduino, Platform IO. We're going to look at those, and you'll find that those other modules that I showed you, they are been around for a while, and they are also, you might buy those on AliExpress, and they are well documented here. This is a random nerd tutorial on how to use Bluetooth with ESP32, and there's lots of information online about these things. And when it comes to STM32s, those little boards that I showed you, they also are coming from ST. It's a company that makes them. They have their own website, but there is also, see, this is that blue pill one. There's plenty of information available on these things, how to get them going. Comparison here between that and the Arduino. As I said, it's a lot more powerful. Has a CAN bus, which is used on automotive devices and so on. Like in your car has like a CAN bus socket on it, and you can communicate with the controllers and all that sort of thing in your cars. And it's also used in other devices and industrial things. So here's an example of how you hook it up to a little screen and some button, and how you have to set up Arduino to make sure that it is a recognized board. And this is the sample code that they are talking about, and then this is coming to uploading the code to the STM32. They are using that FTDI board that I showed you, but as I said, I use the ST-Link one. Anyway, there's plenty of information there, and the official website of the people that make those chips, st.com, they have information on their website on it. And those two boards, they have the F1 version, 72 megahertz, and the one that I showed you on that other board, there was an F4 version, which is 180 megahertz. It's a more higher performance one. There are some boards available I've seen on AliExpress with the F4 on it as well, so if you need more performance, but I prefer to use the ESP32 for that, because it runs at 240 megahertz and it's a little more powerful as far as I'm concerned. Then we have Seeed Studio. They have lots of information available as well. They have a wiki there with instructions. This is for the Chow IP2040 that I've been looking at because I've been playing with it. Tells you about it, 133 megahertz and so on, 2 cores, pinouts, and they get started with Seeed Studio stuff. They also tend to have a GitHub, the good ones do, like this ESP32 and so on. You'll find that there is M5, this is a branch we'll look at in a minute. They have GitHubs with all sorts of information on it and code you can download and all sorts of things. CAN bus library, you can download that library and talk to your car. And the next company with that M5 device that I showed you, this is they have these devices and stuff that plugs into them, little kits and what have you. I actually have one of these AC measure units. I was planning to put that to its paces. That'll be another video if it works. With that you can actually measure the AC voltage, power factor, wattage, and all sorts of information, which would be useful to put in some sort of instrument if you're working with AC voltages. And they have M5. It's called M5 stack for a reason. You see, if you scroll this up, you'll see they've got these little modules you can buy, and they'll plug together. And I have different families there: stack series, stick series, atom series. So lots of interesting stuff there. They too, like that AC measure device, I'll put a link there to that GitHub there. It has sort of a demo code and all sorts of stuff that I'll be looking at. I haven't studied it yet. Oh, that's that device here actually, that we're talking about. As I said, Espressif has their own development environment, but I didn't like it, so I tried it but deleted it. Arduino, of course, the development environment is over here. Took a while to come down. So you can download the software from here. Arduino IDE 2.11, and for more extensive projects I tend to like using Platform IO. It's a bit more powerful than the Arduino, and it actually runs within Visual Studio Code. And as I said, if you're looking for these devices, you can find them on Amazon, on eBay, and this is AliExpress. I typed in STM32 and you will find that, see, there's that blue pill one. This one here, they seem to be offering that ST-Link version 2 with it, like I use. A little cable plugs into those pins, and there's lots of those, lots of options. These ST-Link things come in different colors, but they're all the same. And likewise ESP32, lots of them, different versions. As I said, if you buy from AliExpress, make sure that you that the board is supported by directly by ESP, by the Arduino and or by Platform IO. If it's not already there, just don't buy it. Find one that is, because it can be a hassle to set it up. This is similar to the ones that I have. There is one with an inbuilt antenna, and there's one with the little socket on there, which is what I have, because I like hooking up the external little antennas. Lots of those, and even with the Tiny 85, see, there's the devices that I use, that is a DigiSpark Kickstarter thing. There are actually, you can buy the chips by themselves. You can buy a version that is surface mount if that is your preference. Here is a little board that the actual chip will plug into, that you can actually program it with as well, and different options. Okay, that is it for now. I just wanted to do an overview to show the kind of controls that I have and some of the tools and software and where these things came from. in future videos, when I'll be using these things, we'll be doing projects with these microcontrollers, and I'll put them in the same playlist under microcontrollers, and there will be more extensive explanation of how things are set up and many more details. This was just an overview. So if you like these videos and you want to know more about these microcontrollers, including the projects that are going to be doing with them, then please hit the subscribe button, the like and the bell button and all that kind of stuff, so that you'll be notified when they will be available. And that's it. I'll see you guys later.